Mandaluyong City, the Tiger City and the shopping capital of the Philippines, is located in the heart of Metro Manila. Despite being the sixth smallest city in the Philippines, it's recognized for its vibrant urbanized commercial hubs, bustling with business opportunities that led to its rapid economic growth. Historically speaking, during the Spanish colonial era, Mandaluyong City was named San Felipe Neri, after the apostle of Rome, Saint Philip Neri. They even built a church in his honor, named of course San Felipe Neri Church, which is the oldest church in Mandaluyong City. The name Mandaluyong actually has many colorful origins. Local folklore attributed the name to a love story between Manda, a chieftain's daughter, and Luyong, hence Mandaluyong. And another comes from the previous rolling hills of Mandaluyong, described by a navigator named Acapulco as being hit by large ocean waves called the Luyong. Lastly, it was possible that Mandaluyong comes from a native tree that used to be found all over Mandaluyong called luyong, but it is now more commonly known as anahaw. Due to intensive urbanization, most of the rolling hills of Mandaluyong have been flattened out to gentle slopes, making the low-lying inland prone to flash floods during heavy rains and typhoons. Mandaluyong City is actually bordered by two major waterways, the Pasig River on its south and San Juan River on its west. Now, let's discuss the geologic structure, the lithology, and the geologic hazards that affect Mandaluyong City.
And now, let's look at the geological structure of Mandaluyong City. The Mandaluyong City is mainly built on the Guadalupe Tuff, also known as adobe bedrock. This is a hard volcanic rock that forms a strong and stable foundation on buildings, roads, and other infrastructure. On top of this bedrock is a thin layer of clay-rich soil, specifically the Novaliches City loam, adobe, and Guadalupe City soils. The terrain of Mandaluyong also varies across the city. The southern-western area is mostly flat, while the rest of the city has gently rolling slopes. The northeastern part is at the higher elevation, while the areas along the Pasig River are only about 3 meters above sea level and are protected by concrete embankments. These differences in soil type and elevation affect how water flows across the city. As a result, some low-lying areas are more likely to experience localized flooding during heavy rainfall. Overall, Mandaluyong's strong bedrock provides a stable base for urban development, while its terrain and soil conditions influence drainage and the city's susceptibility to certain geologic hazards.
Moving on to Mandaluyong's lithology, we know that the city is lying on top of the Guadalupe Tuff Formation, which is a rock foundation that consists of the Alat conglomerate and the Diliman Tuff. The Alat conglomerate mainly consists of massive, poorly sorted conglomerate of round pebbles and small boulders. Because of its dense packing of rocks, it has high structural stability and has minimal risk of settlement under structural loads. Meanwhile, the Diliman Tuff consists of mostly flat-lying sequences of medium to thin-bedded fine-grained vitric tuff, welded pyroclastic breccias, and intercalated to fissure sandstones. This is also where Mandaluyong's foundation of compact and massive adobe is, which is a localized name for volcanic tuff. Adobe can also be used as dimension stone as it is easy to shape and hardens over time. It is also described as a basaltic to a trichidicitic pyroclastic flow deposit with a silica content of 54 to 65% and consists of mostly volcanic glass. That said, if we look at Mandaluyong's surface area, we will find that it is mostly covered in granular clay loam and granular clay, specifically Novaliches clay loam and Guadalupe clay, both of which originate from adobe. Novaliches clay loam is reddish-brown to brick red in color, moderately fine-textured, composed of sand, silt, and clay, has a high CEC, which is cation exchange capacity, and high base saturation, while Guadalupe clay is dark brown to almost black in color, derived from weathered, water-laid adobe, can form hard blocks or prisms, ribbons very well, and has a slightly acidic to neutral soil pH level.
Next, let's talk about earthquakes. Mandaluyong lies within Metro Manila's seismically active zone, and the main structure to watch is the West Valley Fault, a roughly 100-kilometer active fault that passes through Bulacan, Rizal, Laguna, Cavite, and several urbanized cities of the National Capital Region, including areas right next to Mandaluyong. PVOX closely monitors this fault because a full rupture, often called the Big One, could produce a magnitude 7.2 earthquake with intensity 8, shaking strong enough to topple an estimated 168,000 buildings and cause more than 33,000 fatalities across Metro Manila. Even though Mandaluyong is not directly cut through by the fault's map trace, it still sits within the zone that would feel strong shaking during a major eruption. In that said, the city's own vulnerability assessment shows its geology works in its favor because it sits on adobe bedrock with only a thin soil layer on top. Mandaluyong is classified as very low risk compared to other parts of Metro Manila, and liquefaction is considered very minimal here as well. Recent research adds one more layer to this picture. A segment of the fault called the dilational jug in the southeastern part of the metro has shown decades of slow, non-earthquake movement linked to groundwater extraction. Follow-up studies suggest that this creep could still transfer stress to the fault's fully tectonic segments, which are capable of producing earthquakes above magnitude. And this shows that seismic hazard in the region isn't just about fault rupture. Groundwater processes nearby can also influence stress on the fault system. Building on that, the main geologic hazard for Mandaluyong is strong ground shaking coming from the West Valley Fault during a major earthquake, rather than surface faulting happening within the city itself. PVOX generally recognizes liquefaction, ground rupture, landslides, and tsunami as secondary hazards linked to the fault. But for Mandaluyong, only liquefaction is relevant given its inland location, and even that is rated as minimal because of the adobe bedrock foundation. This puts Mandaluyong in a much better position compared to the low-lying alluvial and reclaimed areas of Metro Manila, where loose, water-saturated soil makes liquefaction far more likely. This pattern is also supported by nationwide data. PVOX liquefaction suspectability maps show that a majority of Philippine cities are located in liquefaction-prone zones, and post-earthquake studies like those from the 2022 Abra earthquakes confirm that liquefaction tends to happen in lowland, saturated soil areas rather than places sitting on solid bedrock like Mandaluyong. On the institutional side, the city has taken steps to prepare for a potential major earthquake. A local assessment rated Mandaluyong strongly in terms of its legal framework, hazard and vulnerability mapping, and disaster risk reduction planning. So, while the city's physical exposure to earthquake-related ground hazard is comparatively low, its disaster governance and hazard mapping remain key tools in managing whatever risk remains.
Groundwater serves as a significant water resource within Mandaluyong City. Despite the presence of a centralized water distribution network, groundwater contributes to supplying water for numerous residences, commercial establishments, and industries. Given the city's location atop groundwater tables, deep wells are employed to access this subterranean water, particularly in regions not linked to primary water supply. Currently, Mandaluyong has 2 deep wells installed by the Presidential Task Force, 60 public deep wells for households, and 18 deep wells for industrial use. The water from these wells is sent to a pumping station with a capacity of 460 liters per second before it is distributed throughout the city. The city's water distribution can deliver up to 219 million liters of water per day, helping meet the needs of its residents. To make sure the water is safe to use, the City Health Office regularly tests and monitors its quality. This helps ensure that the water meets national drinking water standards and protect public health. Overall, groundwater remains an important resource that supports Mandaluyong City's water supply and helps provide clean and reliable water for the community.